Welcome to Lesson 70, Part 1. You're going to need some kind of straight edge, something that has a side that's straight, and your highlighter. So, Lesson 70, Angles and Degrees, pages 13 and 14. Angles and degrees. So our content objective for 4th grade MD measurement data C5A. I can understand that angles are measured with reference to a circle, with its center at the common endpoint of the rays. Language objective. I can use vocabulary related to geometry to describe angles and degrees. Social objective. I can work with others to create models of angles and degrees. So some terms we're going to use. Intersect. Intersect, to cut across or through, to divide by passing through. So they cross each other in some way. The lines intersect the butterfly and each other. So it means to cross. Arc. A-R-C, arc. A portion of the circumference of a circle. So the circumference is that outside line that makes a circle. And an arc is a piece of that, just one portion, like A to B is just one portion of that circumference, and we call it an arc. And we use an arc above the letters to know that we're talking about an arc. Circle. Circle is a flat 2D curved and closed shape with no sides and no vertices. All points are the same distance from the center. So every point on the outside here is exactly the same distance from the very center point. Circumference is the distance around the edge of any circular object. So it's like the perimeter for a circle. Anything round would be your circumference. Clockwise. We use these terms, clockwise and counterclockwise, a lot to let you know the direction. So clockwise means in the same direction as the movement of the hands on the clock. So if you look on the wall and see how the hands of a clock move, we call that clockwise when it moves in this direction. Counterclockwise is in the opposite, counter is opposite direction of the movement of the hands of the circle. So it will move this direction, just the opposite of the hands of a circle. Angle measure. The size of any angle measured in degrees. And what we're looking at is what part of the arc does it cut off in degrees. Degree. We use this little circle symbol to indicate degree. It's a unit of measure for angles. There are 360 degrees in a circle. Now you may know degrees from temperature because it measures temperature as well. It measures heat, the amount of heat, and it uses the same symbol. But this does not have to do with temperature at all. It just has to do with how many 1 degree angles will fit inside of a circle, and there's 360. And then we use that to measure with other angles as well. So these are two things that we will be looking at coming up. We have a circular protractor and we have a semicircle protractor. An angle is formed by two rays sharing a common endpoint. An angle is measured with reference to a circle which has a total of 360 degrees. So we look at an angle as a part of a circle. How much of that circle is it? Out of how many of those 360 degrees does that angle show? Degrees are used to measure angles. An angle that turns through 1/360th of a circle is 1 degree. A protractor is a tool used to measure angles. So we have a circular one here and a semicircle one. We're going to be looking at both coming up. Most angles you will measure this year will be under 180 degrees. So we will use a half circle or semicircle protractor to measure angles. This is the one we're going to use the most. Okay, so just a few angle benchmarks. This one right here, you should be used to seeing that square now from the previous lesson. When you see that square, it's a square, perfectly square angle. That means it's exactly 90 degrees. 4 of these will fit in a circle, and you'll see them right here. Here's 1, 2, 3, 4. Here's that straight angle. That's two of those 90-degree angles put together. 90 plus 90 is 180. So a straight angle is 180 degrees, like we talked about in the previous lesson. Now, if we cut 90 degrees out of a circle, how much is left? Well, 90 plus 90 is 180, plus 90 more is 270 degrees. The rest of that circle, this angle right here on the outside, would be 270 degrees. And if your angle is the entire circle, it would be 360 degrees. So those are ones that are going to be very important even up into high school, knowing your 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, up here. The unit used to measure an angle is called a degree. There are 361 degree angles in a circle. So we start here, 0, and we actually go counterclockwise on this. So we go 0, counting by ones up to 90, counting by ones till we get to 180, 270, 360. Remember, an angle is formed by two rays that share a common endpoint. And when we look at this, that common endpoint is going to be in the very center of the circle. This circle shows two rays that share a common endpoint. One ray is at point 0. Find the degree to the other ray is pointing to. So we look where the other ray is pointing to, and it's pointing directly to the 90 degrees. And that's exactly 1/4 or 1/4 of a circle. It is 1/4 turn from 0 to 90 degrees. So there's 490 degrees in 360. And that measures this arc of the circle, where it intersects that arc. Okay, so now this is where the straight edge comes in. It does not have to be perfect on this, but we want to draw an angle that has a 1/4 degree turn. So we just look at that. We want to try to make a 90-degree angle. So with your straight edge, we want to try to go straight up if we can from that center point. Your center point should be peeking out a little bit from your straight edge. Make sure you're right along it. Put your first ray. Okay, and then do your best to make that 90-degree angle. It's okay if it's not perfect, but you should have a straight edge on it. Oops, I missed my center point. That's where it's helpful to have a pencil instead of a pen. So the part that we want with our highlighter then is to shade in what we're talking about when we're looking at that 90 degrees or the 1/4 degree turn. Here, draw an angle that has a turn greater than 1/2. So we want it to be greater than 1/2. So we're going to start here at where 0 would normally be on this side. Oops. I missed my center point again. Again, this is why it's important to use pencil. And then I want it to be past the straight line. So this whole area right here would be an angle that's greater than half of the circle. So greater than 180 degrees. Draw an angle that is closer to one whole. Interesting. So what we want to do is have that first ray. Oh, that one I got on the center. That's good. And then really close, almost completing the circle, because this is where 0 is to start, and we want to go all the way around to 360. So if we're looking at almost the whole circle, this is the part we're looking at for the angle. So close to 360 degrees. Kind of looks like Pac-Man, especially since I'm using yellow. Here, draw an angle that has a turn less than 1/4 of a circle. So here, getting better with getting on that center point. It has to be less than this one right here. So anything up here that is less should work. So the part of the circle we're looking at is this part right here. Okay, so we finished part 1. Now on to part 2 with our 3-column notes and investigating more with angles and degrees.